The side of Santoor, and this tuning key is currently attached to the tuning peg here. And one of the problems with tuning Santoor, or maybe other instruments similar, is that here the peg is attached to this wooden box just by some drilled hole here, and there are very fine screw threads here. So it's really held in place by the tension of the string. And whenever you try to tune the specific string, uh, you would have to apply some pressure. You keep turning this very gently, very slowly, maybe like a couple of degrees of turn at any given time, but then it would not budge. And then all of a sudden, after 5-6 turns of few degrees each, it would jump the notes from maybe half a note up and down. So there is a big amount of hysteresis that is involved in tuning this instrument, and the software algorithm that is used to make this tuning automatic has to take into account hysteresis and work around it. It was important to understand what is the torque requirements for tuning the pegs and finding the right size of the motor. So I used a bunch of plastic tubings that I had lying around in my garage, connected them to each other, and created a lever kind of mechanism that I attached to one end of the tuning peg. And I kept adding the tubes until under the self weight of those tubes, the pegs started turning. So using the simple formula of the weight of the lever multiplied by gravity acceleration multiplied by the lever length, I found out I needed 4.45 Newton meter torque motor, and that's roughly 630 inches of torque. So I used a DC motor with 100 to 1 gear ratio to meet this high torque requirement for my project. Here is the key, original key, which we cut off and used for connecting to the shaft of the DC motor. These are the different attempts we did which failed, of course, to connect the key to the tube so that it can slide in and out. As you can see, it is really hard to get the slotting done with the tools we had. My colleague Bruce, he helped me in making this. He has a milling machine at home which we used to cut the slot, and you can see it was easier to do it with this brass tube. With steel it was a lot harder and it was not easy to make it. There were a couple of things we tried which failed, and initially when we tried and even for brass, some of the initial efforts did not go well. They were not aligned, or they were going out of not were in straight line, etc. The original one we tried, that one, the Santoor pegs really they warped the brass tube, as you can see here, because the force needed, the torque needed to turn the Santoor pegs is enormous. So brass tube was not able to take its force, take its pressure. So finally we ended up using a steel tube, and we tried different mechanisms to make the slot work, and finally we got one way to make it work. This is the Santoor, and here are the pegs which are mounted on the side of the Santoor, and the strings are attached to these pegs. As you can see, the pegs have a square shape, So the key that is used to insert in these pegs and tune also has a also has a square shaped opening. This is the key that is used for tuning, and here you can see the shape of the opening, the key. It's a square one. Here is another key, and the main problem with square key is how do you easily make the key go inside here, because based on there are a lot of ways that the key will not fit. There is only one of four ways that the key will go inside. So for example, now it goes in, but even if it's off by a little bit, it will not go. So this has been one of the main challenges in designing the Santoor tuner. Here, as you can see, the switch is now engaged. That's what stops the motor from moving forward. And now, after that, we can just rotate the DC motor until it engages, and as you can see that the spring pushed this the flexible part of the shaft forward, so that the shaft is now completely engaged. If I try to turn it one more time, you can see this actually is engaged now. Different springs that I tried out for connecting the key, the tuning key, with the motor shaft. Finding the right size was important, as well as having the right compression strength was equally important, because if it's too weak, it would not push the shaft all the way in to engage with the tuning pegs, and if it's too much force, it would bump against the tuning pegs with heavy force, potentially causing damage and wear and tear in the long term. As you can see, Santoor has a trapezoidal shape, but this main axis of the instrument here is mounted perpendicular to this side of Santoor, and it's not parallel to this other side. And the main reason for that is these pegs which are coming out of side, over which the strings are mounted, they are basically parallel to this edge. They are not perpendicular to the trapezoidal side, and that's a very important design consideration that I kind of overlooked at the initial phase, and I had to redesign some parts of my project to work with this constraint here. That's why it's important that the X and Y axis of this instrument to be parallel to this line, and we should not use this trapezoidal side of the Santoor for aligning the instrument with the pegs. One of the challenges, as you can see, in designing a automatic tuner for Santoor is, since this instrument is hand built, you can see the different pegs are not aligned perfectly, either in a straight line, horizontal or vertical. So there is, because of those inaccuracies, the instrument that's used to tune it has to allow some tolerance in terms of perfect alignment. Otherwise, this will not work. This is the universal coupler I ended up using. It is a different design than the one which is this one here, and this one has basically grooves, continuous grooves here, and that is used for basically balancing the misalignment. But I found out that this specific coupler needs some kind of guided rail or a shaft that has support on both ends. Unfortunately for my project, the coupler here is taking the weight of this side here, which is kind of considerably long shaft with the tuning key, and that was simply not possible to use this kind of coupler because it would bend. This one is fairly strong, and that's why I don't need any extra mechanism to hold this in place or give support on this end. I was trying to initially have one of these rods give support to this shaft, but as you can see, this itself is a pretty flimsy um, bar, so it barely just doing its work of supporting the servo and the limit switch here, so it cannot be used to support the other end of the shaft here. That's why choice of this coupler was a better choice. There are these stopgap measure switches connected at the end of the whole assembly, so that in case there is a problem and the shaft is engaged with the peg and it cannot revert back easily, it cannot go back easily, the whole assembly will try to pull, causing these switches to trip, and it will stop the motor from moving. It will avoid basically any damage to the motors. Hopefully these switches don't have to be used, but sometimes they may be needed. There is a servo motor connected to the end of the shaft with a guitar pick connected to it, so that it's used for plucking the strings. Here is the demo.